Yeah, thanks very much indeed, Dermot. Let's look at how handy these robots can be. Boom, boom. This is, of course, a prosthetic arm operated by Sethu Vijayakumar. Sorry, Sethu. We've seen you this morning, of course, before. You're going to show us and tell us about this thing. It's quite a familiar sight, actually, the prosthetic arm, isn't it?
Yes, so this is indeed a prosthetic arm which can essentially help patients who've had a disability, lost a limb as part of an accident. And let me just show you how it works. So I'm strapped on with an EMG sensor. So this has got a sensor which basically measures the activity of my muscle. So when I move my hand, it can pick up the activity on my muscle. And this is now connected through some electronics onto your hand. And now what I'm going to try and do is turn this on, and you can see that when I move my hand, the arm and the fingers respond in a similar fashion.
Yeah, we're going to go for the drink of water.
Let's have a go.
And tell me about the beauty of the actual fingers itself.
Yeah, so basically the volition of opening and closing comes from the person who's controlling it, but a lot of the smarts in terms of when each of the fingers should close to adapt to the different kinds of objects it wants to grasp comes from the smarts in the hand. Right. So that's why you can grab a variety of objects all the way from a cylindrical object to a ball, which is rather complex object.
Yeah. So you're operating the arm, but when it comes to the hand operates itself.
So this is what we call shared autonomy. So we are mixing the best of both worlds. So humans are very good at perceiving where an object is, what an object is, perhaps not so good at doing precise actions. Robots, on the other hand, are very good at doing very precise actions, repeating things. So if you marry the best of both worlds, the volition, the intention comes from the human, the actual precise movement comes from the robot, and there is no danger of the robot running away, doing its own things, because you've got human in the loop.
We have the arm. Where does the technology take us next? To legs?
So indeed, so this is one of the top-end prosthetic hands, upper limb prosthesis. Indeed, there are other elements of the disability spectrum that we're trying to address. One of them is indeed the lower limb amputations, so legs. And we are indeed going to show you an example of that soon.
Quite complicated, all of this. In fact, take a look, Dermot, at the what I think is called a differential equation on the whiteboard in Sethu's office. This stuff takes years, doesn't it? And how many more years do you think before we get to the stage where we have humanoid robots as a regular sight?
I think the fundamentals have been around for a while. It's a question of getting it in the right package. So you need sensors which are the right form factor. You need sensing and actuation which are fast enough. But the technology, the actual, the basics have been around for centuries.
Great. Sethu, thank you very much indeed. More here later from the Edinburgh Centre for Robotics.
Okay, James.